everything is transparent. A lot of bots or like other people are observing them. This is somehow the heart of the problem for like front running and like toxic MEV or like leaking alpha on chain. So the way that we see privacy is a spectrum. I don't know, toxic MEV prevention, front running protection, and also the contents, your alpha, your strategy can remain on chain. It's like decentralized, it's transparent, nobody can censor you. The current situation in Ethereum is like failing the decentralization narrative and like the censorship stuff. We and a lot of people really don't like that.
Welcome to the Bare Metal Podcast.
Good afternoon, everybody. Welcome back to the Bare Metal Podcast. I'm Ship the Code from RockYX, and today with me here is Peyman from Fairblock. Welcome.
Hey, happy to be on your podcast. Thank you for having me.
Super. So let's dig straight in. Tell us about Fairblock.
Yeah, so Fairblock is a system for delivering programmable privacy to decentralized applications in a chain agnostic way. So the way that I see Fairblock is that we want to give developers with more freedom to build better and more applications with the freedom for encryption of transactions, and also giving the end users the optional freedom to encrypt their transactions and protect the contents of their transactions from prying eyes.
That's a sort of mouthful. So let's dig into these sort of individually and understand a little bit of what the meaning of those terms is, and then let's see how this would be applied to some use cases. So when you say programmable privacy, can you just give an example of what that means and how that works?
Yeah, sure. Currently, in the apps, when you submit a transaction, it's even before ordering and inclusion in the block and during execution, everything is transparent. A lot of bots or other people are observing them. And this is somehow the heart of the problem for front running and toxic MEV or leaking alpha on chain. And it's limiting a lot of applications. And this is one side of the spectrum. And there's the other side of the spectrum, which is Zcash or complete privacy, which comes with a lot of regulations and mixing the bad players with good players. So the way that we see privacy is a spectrum, right? It's there's a fuzzy logic here. So we should play with your privacy, the optional leaking some part of the data for better execution for regulatory reasons and or transparency. So what we can enable is that we can encrypt the transactions with certain conditions for decryption, and once those conditions are met, we can decrypt them. So it can be we can encrypt transactions and decrypt them for a certain time. After a certain time, we can decrypt them once a certain price has happened, or we can simply using fully homomorphic encryption, we can keep them private as much as you want. So this is the general ideas. And with this kind of tooling for developers, we can build more applications that enjoy encryption, and also end users can have hopefully a seamless experience for sending private transactions.
Okay, that's pretty interesting. So I'm trying to model this in my head, how that works. So I want a transaction encrypted somewhere. Let's say I have motivation to submit an encrypted transaction, right? So somehow in my mind, your Fairblock has to create some sort of public key for encrypting this. And then the transaction is encrypted and sent along. It has to be sent somewhere, I guess, to the target chain. And then at a given time, decryption needs to happen. So who generates the key material? Where is it stored? Does anybody have access to that? Is it possible to somehow subvert this? Can you tell us more about how this part works?
Yeah, sure. So we have a blockchain and Cosmos SDK chain, which serves it's not just for Cosmos. It's it can provide service Axelar to all of the ecosystems. The sole purpose of the chain is decentralized key generation. So we have a chain just because there's economic layer of security. There's social reputation. It's not just us and a couple of friends running Dockers for our key generation. So we will have decentralized key generation on that chain, and after the decentralized key generation without a trusted party, all of our validators will have a private key share. And we don't run DKG frequently because it's expensive. And using those private key shares, our validators will be able to send their private key shares like once the conditions are met. So this is the side that we will generate a master public key for the whole system, and the validators will have their private key shares, right? From the other side, we have like encryption SDKs that can be integrated with the front end of applications like, for example, Osmosis or like Cosmos chains, like layer 2 applications. And hopefully once we've shown the traction, we can integrate it in like MetaMask or Kepler. And users will like see no difference. They go to the normal application, normal like logic for execution, like their front ends, not our front end, and then submit their normal transactions. And it can be enabled by default, like HTTPS, that everybody knows it's good for protection encryption. They can see the lock button, but like they don't know what's happening. They just know it's important. Or it can be a simple toggle button, right? So you can enable, like you can just choose by default, or like just turn on the toggle button for encrypted transactions. And for some of the applications, you can also specify the conditions for decryption. It can be a price, a time, or something. And then the transaction will get encrypted in the browser. So once it goes into the network, in the communication layer, it's already like ciphertext. And that encrypted transaction will be stored and sequenced in the L1 or the L2 that we are integrating, and later in the Ethereum mainnet. And the transaction will be there. And once the conditions like time, for example, the current block, the end of current block is reached, we in our chain we generate a like single private key. This is like one of our like winning points, that we don't like generate like multiple keys for all of the transactions. We generate a single key for all of the transactions are encrypted toward the same condition, and then we relay in the same block in Cosmos chains, and we'll relate like using something like a relayer or IBC or like XLR GMP to other like ecosystems. And then the decryption and execution, all of them happens in the other chain, not in our chain.
So the other chain needs to request a decryption, like from your from the validators, or request the decryption key, and the validators on your chain decide whether it's the right time to release the decryption key. Then the transaction is decrypted and executed. For the general condition, this is correct. But for some kind of applications that we are starting with, like time block encryption, we don't even need to receive the request, because like they are encrypted toward our time block numbers, which can work for all of the chains. And then once that block is reached, our validators automatically send their private key shares. The same is for prices. Like for Osmo meets like that specific price for limit orders, we just like send them. Like we don't need to receive the request for that. But with the card, like with the like, or like also for like for the general conditions, the relayer or the chain can submit the request. It can be a smart contract event, like an on-chain event, or even a real-world event that they can submit the request. Mm-hmm. So this seems to provide a very wide range of possibilities. So let's try to zoom in on some of those. Are you guys working on any specific projects right now that you can talk about and sort of illustrate like what problem does are you solving here?
Yeah, sure. The main focus of us, like our main goals, are generally on the DeFi side for like things like, I don't know, toxic MEV prevention, front running protection, and also not on the like arbitrage and good MEV side, but just we are working, for example, with Skip on building like encrypted transactions to protect users from like toxic MEV stuff, which is gaining like more importance with the current events that is happening with like Celestia. And also for like we are working like, I don't know, we have got some like traction from like HFTs or like professional traders that their barrier for them to enter the crypto space is not leaking their info, the contents of their transactions. So this is really important for them, so they can put limit orders on chain, private intents on chain without leaking what their strategy, their alphas, at least before execution. And so this is the general focus of us on DeFi and like the encrypted mempools on like all of the ecosystems. But we don't really want to be one of another ZK projects that just work on moon math and like research papers. We are shipping products frequently. We are starting with easier products first. So the first product that will be in market will be the private governance idea that we have. So just like normal elections in like any democratic countries, call it privacy or not, you don't show your vote to other
reveal
people.
your vote, like necessarily.
Yeah, right. It's like we can call it privacy, but nobody calls it privacy in real world. It's just a basic execution logic, right? So in Cosmos, with the high, like, I don't know, drama per second that we have, it's really important to keep your votes private, at least for during the execution. We don't want to force it. We just want to give the optional freedom. We can even have a hybrid proposal. Like some people just can submit like plain text votes. Some people can encrypt them. And so like we have a private governance module that can be installed by all Cosmos chains. And the users can go through the same experience, hopefully on like Kepler or like other like wallets once we've integrated with them. And they can just turn on the toggle button to encrypt their votes. Or if they don't want, they can just not do that, right? It's just something that adds the flexibility. Yeah.
So that's written just as a new Cosmos SDK, and I can drop it into my chain code. Just use it as another sort of private Go for encrypted Go.
Yeah, it can be integrated. Yeah, it's a really easy integration. It's just like few hours for integrations max.
Okay, so and that allows, when I send my vote, it can be optionally encrypted during the voting period, and then when the vote is being tallied, when the sums are being computed, then the vote is then each of the votes is decrypted again via this infrastructure, via the validators revealing the key. Then and that's where I guess the single key comes into play, right? It's for this one governance vote, so you can use a single key for all those, decrypt them all at the same time.
Exactly.
And then compute the votes, and then the results are public.
Yeah. So based on the traction that we got, like people actually want to make all of the encrypted transactions transparent after the proposal. But there's also some people that actually want to keep there's like no perfect answer, perfect solution. It depends on the proposals. For some of them, we need to keep the votes even private after the proposal. So for that, like we are going to also like provide the option for fully homomorphic encryption, that like everything will remain encrypted even after the proposal, and we just need to decrypt them like in certain events. But the like initial product everything will be decrypted after the proposal for transparency.
Okay, so if we can go, so private governance module makes sense to me. I want to use it because I want to hide my vote optionally, and I want to be able to do that if I choose to do so. Therefore, I'm interested in your tech, and I'd like my chain to support like private governance. Makes sense. Can we go back to the idea with the sealed auctions that you guys are working on, Skip? Can you sort of expand on that? Like, is this auctions for inserting transactions into the blocks, or auctioning off the blocks? Which bids are sealed, and who's making use of your tech?
Awesome. So like auctions in general, the first price auctions are public. You can see the other people's bid, right? Like normal seal bid auctions that people put their bids inside the letters and other people cannot see them. We can enable that, right? We can build the letter bugs. And it can enable the like second price auctions and seal bid auctions in general, which is like theoretically based on like mechanism design research, provides better value to bidders because they have incentives, financial incentives to bid the correct value that they think. And it can be useful for the seal bid auctions in general can be like useful for a lot of applications. Initially, we are starting with like NFT auctions with Stargaze, with our partnership with Stargaze. So the cool thing is that it can provide better value to bidders. And also, in this case, it helps with the UX because right now they're extending the auction period 15 minutes after the last bid, right? Every time that you submit a bid, it extends like for 15 minutes. But with a seal bid auction, you have better value for the users, and also it can be ended in this like predetermined time. So we have like better efficiency.
So
right?
Can you explain why is Stargaze extending the auction now by 15 minutes after every bid? Why is that happening?
Yeah, it's because of like MEV bots, like NFT MEV bots, and and also like this is the same for even private governance. Like because in private governance, you should hold your votes. Like a lot of people hold their vote for the last people, or like they change it in the last minute to see like what's happening with the other guys, right? They don't want to. Also, they want to avoid the dramas if they vote quickly. But if it's encrypted, they don't have that incentive to hold it. Like so, the efficiency can be like we can have a like proposal even faster, right? So Also on the Silbit auctions on the other side with the skip, right now in like Proto-Rev or like what they are doing, other no, sorry, for the like bundles that they are doing with skip, the validators are bidding, right? So it's better for them also based on like skip's feedback that the votes should be like the bids should be encrypted for the top of the block. So we are working with them like after ABC
the searchers are bidding.
Yeah.
The searchers are bidding, right? So,
yeah.
The searchers are bidding at the validator that's going to build the next block. The searchers are bidding each other, bidding each other and trying to win the next block, right? Okay.
Yeah, sorry. I think I mentioned like validators because they work together, but yeah, like searchers are bidding.
That's why I was confused.
Yeah, sorry. So searchers are bidding for the top of the block, and it's an like Silbit auction, so it's better for them to like any like auction to keep them private for like second price auction or just a Silbit auction. So this is one thing that we are doing with Skip. The other thing is just basically we have block SDK, and we can have like multiple lane of transactions. Like one of them would be like for like good MEV for arbitrage, and one of them can be for encrypted transactions for all of these applications that we are mentioning, and like for MEV, like for front running and like toxic MEV protection. And like we've already.
If you have a multi-lane sort of mempool, how do you prioritize the lanes? Are the encrypted transactions somehow prioritized compared to the plain text ones, or is it first come first serve?
Yeah, it depends on like it's the choice of the chain itself. But the idea that we initially have is that like the encrypted, the arbitrage transactions, like the highly competitive transactions, which are like for good MEV, just there is some kind of opportunity for example, USDC, like pool, they can be first, and then after that, like we can have our own encrypted transactions, right? There is no need for us to be like, because like our end users are not trying to front run to other people, they just want to protect their transaction. It doesn't matter to that kind of our audience to be that in the top of the block. They just want to like execute the transactions without other people observing them, like knowing their strategy, or like, I don't know, like getting front run. Right?
So in some sense, like I'm thinking the only person who can front run me if I'm using an encrypted transaction is the validator themselves, right? The one that sees the decrypted transaction right there inside the sort of processing the block. They could potentially like sandwich me.
In Cosmos, they cannot even do that. Like in Ethereum, they can do that, but like we are like pushing that with eigenlayer slashing, because if they do that, they can get slashed. But in Cosmos, it's part of the consensus. Like it's like part of the consensus logic, so you cannot even do that. Like they can only see the decryption key after the commitment to the ordering, right? So the ordering will be finalized, and then only after that.
Okay. So there's no way to do this. Cool. Yeah. So there's no way even for the validator to commit. So that means it's really, really end-to-end protected all the way until execution. That's
we spent a lot of time.
So like for me, if we think of a simple use case, like I could just go ahead and say I want to swap X for B on osmosis, but only when the price reaches this, or when there is when the USD value of XY something goes to Y, right? And it can just sit there in the mempool and be waiting until the oracles on your blockchain, on Fairblock, determine that the price has reached this, and then they will release the transaction into the mempool for processing.
Exactly. Like what we have right now is that like the transactions can, like the contents, your alpha, your strategy can remain on chain. It's like decentralized, it's transparent. Nobody can censor you. There's no like centralized bots, right? Like currents, like limit orders services. It's on chain. It stores there. We can store it there like privately, and only once the conditions are met, we can decrypt and execute them.
So you mentioned eigenlayer. I'm wondering if I zoom out, like what's so eigenlayer is not even sort of operational on mainnet. So this is sort of like a roadmap item, right? So if you step back, like what are the areas where you guys want to expand to? Like where do you want to go with this?
Yeah, so like Cosmos was a really great experience for us. Like we started with all of these ideas, we proved like traction, like our execution, and like we delivered this kind of products. And then like, so basically we have the concept of multiple lane of transactions in Cosmos, like encrypted lane of transactions for different applications, right? So we want, like there is the same like vision for Ethereum. It's not coming from us like directly, like eigenlayer people, a lot of people from like Ethereum Foundation are also advertising that. And the concept is exactly the same. The vision is the same, like having multiple lane of transactions. The reason for that is that for more applications, and also more importantly, the current situation in Ethereum, unfortunately, is going toward the same like TradFi situation, and it's like failing the decentralization narrative and like the censorship stuff. We have like two major block builders. They are producing all of the Ethereum blocks, majority of those, and they are filling all of those blocks with sandwiching transactions, which is really bad. It's like centralized. They can censor. They can, I don't know, like generate a lot of revenue out of those, like, I don't know, some kind of privilege. And we and a lot of people really don't like that. And the solution coming from like EigenLayer folks and Ethereum Foundation and I don't know, some other people is partial block builders. So there will be through EigenLayers and like, I don't know, their slashing mechanism, we can have different block builders. We can still have the arbitrage transactions, the highly competitive transactions on top of it, but there is no need for the rest of block to be also proposed by those like highly competitive, like HFT style block builders, right? So after that, we can have this.
So that's the MevBoost++ project, right? That's going to auction off only part of the block.
Yeah, and in that vision, we are working with the research team right now in EigenLayer to take care of the encryption layer of transaction, encrypted layer of transactions. Things are generally the same as like how we are doing in the Cosmos ecosystem. There is like some kind of like execution logic changes and like some technical differences, but there is the same vision and same applications that we are providing in Cosmos. And another thing that we like, it's more practical down the path. This is like a little more long-term for Ethereum mainnet and EigenLayer, but something that will be sooner than that is like the Arbitrum thing that we are doing. Arbitrum recently released like EVM Plus stylus with the cryptographic precompiles in their smart contracts. And all of that means that we can decrypt transactions inside their smart contracts. So we are going like cross-chain with this kind of stuff. And we can send encrypted transactions with the same things that we are doing in Cosmos right now. And the encrypted transactions will be stored on smart contracts on Arbitrum for all of these applications that we just mentioned. And we can decrypt them on chain. So this was a like breakthrough for us on Arbitrum.
So you're focusing, so if you're in Cosmos now, you're exploring the product, you're looking for like what fits. And then the expansion is towards sort of Ethereum and L2s. Like, are there other ecosystems you guys are looking at? I don't know, Polkadot, Avalanche, Near.
Yeah, Avalanche.
Is that something that's on your roadmap?
Yeah. So the priority for us is like EVM, like Ethereum, and like major L2s. And after that, Avalanche is also like down the path like that we've seen like interest from them. Like there is like growing interest from their side for encryption for like some reasons that I can't share now, but but I can say that our end goal, our vision is being some kind of HTTPS for Web3, so users can have the optional freedom, developers have the optional freedom to build encryption, the apps and users have the ability to encrypt their transaction, and it should be seamless. We shouldn't expect users to install like a Rust code or like another wallet or go to another front end to just wait like 10 seconds and like run a code to encrypt their transactions. This is the reason that Tor somehow failed, right? Because Tor, the adoption barrier is really high and it's really slow. So normal people generally doesn't use like Tor, right? But everybody, even my grandma, uses HTTPS, right? So we want to do that. We want to bring it to the fronts of the like MetaMask or like front ends, and it should be seamless. Like it should be either like a simple toggle button in the settings.
Just one toggle button in the UI.
Yeah, or like by default. Yeah.
That's sounds really good if you guys can swing it, make it really easy. I'm wondering, are there any more sort of technological unlocks you're waiting for? I mean, obviously, like EigenLayer mainnet is one of them. if you're dependent on that for ETH L1. But are there any sort of like math and or sort of product blockers that you guys see now that you'll have to somehow circumvent? Or is it a matter of like writing all the software, testing it, shipping it, and getting the product out the door?
Yeah, something that will happen really soon is ABCI++, because with ABCI++, we can execute all of these logics without any delays. Like right now, we have like, we don't have like that much delay. It doesn't really matter, but it's like on the top of the next block in begin block. But with ABCI++, we can do everything in the same block, in finalized block, which is really cool. So this is one thing that we can do really soon. The other things in generally is we are pushing, like working with teams like Zama on using, like, so they have like threshold FEG protocol, but someone should actually integrate them with applications, run the decentralized network for like private keys. So we want to do that, but like FHE is certainly limited right now with like a couple of like opcodes, like the processing time it's not that fast, right? So in a few years, like
it's not ideally fast, yeah. Let's put it this way.
Yeah. So the progress is amazing. So I've started my actual research in Observatory, working in the cryptography lab on FHE, and at that moment, like 4 years ago, it was even much worse. Right now, it's just a little bad. So like ZK, we are seeing a lot of growth and a lot of interest, and hopefully we can have like even like faster, like seamless privacy preserving computation using FHE. We already have that like on EVM. We have like smart contracts. We are like working on that for certain applications, but we need like more work on that front.
That sounds like an exciting way forward. So that's, best of luck to you guys. And it was great to chat with you today.
Yeah, thank you for having me on the show. Really appreciate it.